Hello everyone and welcome. Today we are excited to introduce Forestallers Data Quality Hub, a modern enterprise platform designed to help organizations detect data inconsistency and maintain healthy and trusted data across S/4HANA landscapes. As enterprises continue moving towards AI-driven operations and intelligent decision making, data quality becomes more critical than ever. The reality is that AI is only as reliable as the enterprise data behind it. In S4HANA large landscapes, there are many hidden inconsistencies, incomplete records, and unhealthy data, which can create operational risk, reduce business trust, and impact the effectiveness of analytics and AI initiative. That's why we created Data Quality Hub. Our goal is simple: to help enterprises identify inconsistencies early, improve overall data health, and build a trusted foundation for their AI-ready organization. So in this demo, we'll walk through how Data Pristine helps organization detect enterprise data inconsistency, improve data trust and governance, and maintain healthier S4HANA landscapes, and to support AI-ready transformation initiative through a modern and intuitive experience. So let's get started. Let's start with the architecture first. So what is happening over here is we have our S4HANA on-premise system, which has the OData. Using that OData, we fetch the records on the BTP using the cloud connector. Once we come on the business technology platform, we use this service list like connectivity service, HANA Cloud, and SAP AI Core. Connectivity services for proxy to on-premise, HANA Cloud to store the rule generation and the results. SAP AI Core services we are using to get our LLM model deployed to use the LLM services of the AI Core, SAP AI Launchpad. Uh, After that, we come to the Cloud Foundry where our application is hosted. It's a Python Flask application. We have the whole pipeline running over here. We have the schema discovery at first, where we analyze the metadata of the OData, and using that we do the data profiling, so the statistics, null values, and distributions of the data. How is your data stored? What is the structure of the data? On top of that, what we do is using our machine learning model, we try to detect some anomalies in the data. Using those data, we generate rules using the LLM, which is a service provided by SAP AI Core. Those rules are then showed on the dashboard, which is our Flask application. And then the rule validation comes in the part where we validate how many records got impacted by that generated rule by LLM. Again, on top of that, we have the AI/ML layer where the machine learning model sits, which creates the script. And using that script, we try to detect how many actual records got impacted. We have the LLM deployed by SAP AI Launchpad, and we have the model monitoring in the AI Launchpad. And on top of that, we have the browser-based front end where the user sees the whole application. So coming through the front end, so this is what we have, some KPI cards over here. How many rows got analyzed, tables, and success or failure. At top, we have the models, LLM model, which the user wants to select for the run. As the pricing of each and every models are different, so it depends on the users that what kind of LLM model the user wants to use. And we have the AI system scan button. What happens is we have connected an API right now that will just select the tables according to the sales order and would fetch all the data regarding that sales order. And on top of that, the rule generation would happen and fetch the inconsistencies in the data in your system. So as soon as I click on AI system scan, we have two options: full system and delta chain. So for example, I have already run a full system scan on this week, and the next week again I want to run the pipeline. I don't need to do the full system scan. I can just select delta chain, and from the last week, the new data which got generated in the system, or which got newly fresh data, we will run this pipeline for that data only. So this makes the cost half or more than half of your usage of AI core services. So here we can save the cost. Right now I'll do the full system scan, and I can see rule generation task started, refresh after completion. So as soon as these rules get generated, like I have done the full system scan, so it would take around 10 to 15 minutes to get analysis of all the tables, all the rows, like this many rows are getting analyzed, and I would get a rules group by the run. So over here we see approval summary. What are the accepted rules, rejected rules, and pending rules? So what happens is we have our machine learning model. So there are some kind of settings that the organizations have done specifically for their own organization. Let's take an example for a sales order. I if the company creates some dummy records, some dummy data, and if they want it for their testing purpose, then those data are not ready. Like those data are kind of dummy records, and they should not create an impact in the AI analysis. So those things ML model needs to learn that okay, these are the settings done by the user or the enterprise. So again, I cannot generate rules regarding that, right? So I'll show you how the run looks like. So we have the run according like here, sales order with irrelevant sales organization. So some sales orders have sales org different, or some kind of org which are not available in a system, or something like that. It says numeric anomaly and the status is pending. How many rows are affected? 34. So these are the ID of the records of the sales order that are impacted. Now what happens is if the user clicks on approve, this rule gets approved, and the machine learning model understands that okay, this is the kind of anomaly that the user thinks that this is correct, and the machine learning model would learn from it and generate more rules according to that. Moving ahead, orphan sales order without items. So there are some sales order without some items. So there is some kind of inconsistency, cross-table inconsistency, and these are the records for that, right? Sales order with inconsistent distribution channel. So these are the records for that, 21 records. Contradictory stale flag with recent creation. So there are some stale flags, numeric anomaly in the recent creation of the sales order. So those things can be, checked by the key ID, and if the user approves or reject. If the user rejects this, then this rule gets rejected. And what happens is the machine learning model understands that okay, this is not kind of a good rule for the user, and it would not generate those same rules for that user again. So this is how the whole data quality hub works and how it looks like. The run would take some time. As soon as that run completes, I would show that to you and we can continue from there. Okay, so as we have newly generated run, which is at 4:35 a.m., which we just refreshed and saw. Let's see how many rules and what rules did it generated. Sales order with missing order age. It generated 32 rules for that. Sales order with unused partner rules. There are 32 for that, which is cross-table inconsistency, life cycle anomaly. So these are the kind of rules that are LLM generated using our machine learning model. And we are going to train that model with the user's perspective, that okay, these are the things which we did it intentionally, then we can just reject that rule, and the machine learning model would learn on top of it and then generate new rules in the next cycle accordingly. Okay, this took around like 10 to 15 minutes for the new run, and we can see the new run already running, right? So this is the whole data quality hub that we have created. Thank you.